So today I'm gonna be trying to build this, which the idea is basically to press a key on the keyboard and then build an audio waveform from it. I have no idea how I'm gonna do it, and I'm probably gonna have to spend a lot of time talking to GPT and then researching the information and libraries and stuff like that. The purpose is to learn as much as possible on how to do everything related to Rust and WASM and these kinds of things. So I'm probably gonna already used an agent to create this style. So I'm probably gonna use agents to just deal with HTML and CSS, but I'm gonna try to do the core logic myself, so I can actually learn. And I already did like the beginning here with the help of GPT as well. And what I'm immediately trying to do now is to figure out. So the agent did this naive way here, which is basically hard coding the strings and then capturing the events on pointer also basically when you click on the cell, I think. And this is the callback that it has here. It basically just sets this state of the press keys. And the idea that I have is to build the core logic on Rust, then compile to WASM, and then basically what I'm trying to figure out now is, because I don't want to do this in this way here, I want to capture the actual keyboard event so that I'm not having like this discrete types of things. I want to build like a machine from the keyboard. So you press a key on keyboard, then it sends to Rust, then Rust processes it. Basically, I'm thinking of trying to implement a finite automata or finite state machine or something like this that processes the input from the keyboard and then builds an audio waveform and then sends that audio waveform to the front end again, and then the front end shows on the waveform here, and then maybe I have some options. I was saying to GPT that there's probably 2 different modes that would be cool. One is you press the key and then immediately shows up the audio and then you can play it. And the other one is it allows you to build the waveform by pressing a bunch of keys. So like craft the waveform by pressing the keys. So basically that's what I'm trying to do, is basically map the keyboard to an audio waveform. Just gonna listen to the response and then just go back and forth pretty much.
Yes, with the automaton as the center, I would structure the first milestone differently. The first thing to prove is not sound generation. It is react downward arrow real keyboard event virtual key downward arrow small WASM API downward arrow stateful rest engine downward arrow rest converts observation rightward arrow symbol ID downward arrow automaton consume symbol ID downward arrow result comes back to JS once that works. Sound. Data becomes just another output of the automaton /engine. The crucial point is that you do not need a rest enum containing every possible keyboard key. Your automaton alphabet can be built dynamically. One separate the browser event from the automaton symbol. There are actually 3 things here. Browser observation downward arrow rest input observation downward arrow automaton. Symbol A browser gives you useful raw information like keyboard event, keyboard event, key down, key up, repeat timestamp code represents physical keyboard position, while key represents the logical character /key. Value after layout and modifiers. MD and web docs +1 I would not choose between key and code inside script. Send both. Then rest can decide what constitutes the alphabet. Conceptually, browser, code, key, Q, kind, down, repeat, false, time, 1234.52 downward arrow WASM rest, keyboard input physical, key, logical, Q, downward arrow symbolizer symbol, key or symbol, key, or later symbol, shift key or something learned generated downward arrow and turn symbol ID 17 downward arrow. Finite automaton no, rest MATCH key, W, E, is necessary. 2 the important rest structure is an internet for an automaton. Strings are useful at the boundary, but bad is the internal. Alphabet. You want something conceptually like Q rightward arrow symbol ID 0 W rightward arrow symbol ID 1 shift rightward arrow symbol ID 2 arrow rightward arrow symbol ID 3. The first time rest sees a symbol, Q downward arrow not in symbol table downward arrow allocate symbol ID 0 subsequent occurrences. Q downward arrow symbol ID 0 so your finite automaton deals with state ID times symbol ID rightward arrow state ID rather than string times. String rightward arrow string internally that could eventually look conceptually like rest struct symbol ID U32 struct symbol table string rightward arrow ID rightward arrow string end automaton current underscore state ID transitions. That means the alphabet grows for input. This sounds much closer to what you're describing. 3 I would make the WASM API stateful immediately rather than exporting 3 functions like handle underscore key, generate underscore sound. I'd expose one rest object, engine from key to WASM. Conceptually, JS const engine new engine then engine. Keyboard underscore event, engine.reset engine state and later, engine.render, engine.samples, engine.set underscore parameter. This matters because your real system is inherently stateful. Symbol sequence downward arrow automaton state downward arrow waveform state downward arrow sequencing state. So I'd establish that ownership model right now. JavaScript owns 1. WASM engine handle downward arrow WASM engine owns 1 key 2 wave underscore core engine downward arrow core engine owns symbol table automaton eventually sequence react should not own it. Automaton state. For minimal API, past primitives, not a JS object for v1. I would resist something like TypeScript engine. Keyboard event code, key, repeat. It looks nice, but it introduces JS object conversion /serialization questions before you learn anything useful. A very transparent WASM call is better. Engine.keyboard underscore event phase, code, key, repeat. Timestamp something approximately like phase, integer code, string key, string repeat. Bool timestamp, F64 the boundary then has an extremely obvious memory /data model. With WASM engine, exporting rest functions /classes that accept strings and primitive values is directly supported, and it also generates TypeScript declarations for the exported interface. WASM engine I would probably encode the enginumerically at the actual API. 0 down 1 up not because 2 integers are magically faster, but because that is an uncomplicated wire representation. Inside Rust immediately turned it into Rust enum key face down, up. So JS friendly representation downward arrow strong Rust representation 5. What information is actually crucial? For this project, my v1 packet would contain exactly physical identity code, logical identity key face down, upper key rule time. Event timestamp I would not send. Target DOM element keyboard event itself control key shift key alt key meta key location is composing yet. Why no modifier flags? Because modifier keys themselves can enter your automaton. Shift down Q up. That is actually much more interesting from an automata perspective than collapsing everything into shift Q. You can later choose to synthesize composite symbols if desired. And repeat is useful because browsers emit repeated key down events when a key is held. MDN web docs plus one timestamp is worth including because time is going to become part of key two wave semantics. You already described stroke downward arrow delta t stroke downward arrow delta t stroke eventually that could influence duration phase. Envelope waveform deformation sequencing, so preserving timing information now costs almost nothing and avoids redesigning the input protocol later. 6. Don't make time part of the automaton alphabet. I distinguish symbol identity from event metadata, for example, keyboard input physical key logical Q face down repeat false time. 3198.2 might produce symbol ID 12 but the transition receives context. Automaton input symbol ID 12 face down repeat false t 3198.2. Then later you could calculate delta t current underscore time. Previous underscore time inside Rust. That is important because it gives you two dimensions. Discrete symbol ID continuous time and key two wave is basically going to become an experiment in mapping discrete events into continuous signals. That's a very interesting core abstraction. 7. Therefore your Rust boundary could conceptually be not implementation code, just shape, engine symbol table automaton last underscore timestamp. Receiving keyboard observation physical str logical str phase key phase repeat rule timestamp underscore ms f64 then keyboard observation downward arrow symbol ID downward arrow automaton. Step. Transition result. The word symbolizer is useful here. It creates a clean conceptual scene. Keyboard vocabulary downward arrow automaton alphabet and it doesn't require a giant key mapping. 8. The symbolizer can initially be almost trivial. For example, you can make the Rust engine have an alphabet mode. Physical logical then physical input. Physical rightward arrow in turn logical input logical rightward arrow in turn so keyboard event code key becomes either symbol key or symbol key depending on one Rust configuration. That is one policy, not conditions for every key. Later, alphabet mode, physical alphabet mode, logical alphabet mode composite could exist if the experiment calls for it. I wouldn't implement composite now. 9. Then your physical keyboard handler becomes incredibly boring. This is exactly what you want. Conceptually, TypeScript window add event listener key down, event engine keyboard underscore event down, event code, event key, event repeat, event timestamp, and TypeScript window add event listener key up, event engine keyboard underscore event up, event code, event key, event repeat, event timestamp. No knowledge of QW space 440 Hz C4 D4 exists there. The browser is just functioning as an input device driver. 10. Your virtual keyboard should go through the same conceptual path. Right now you have TypeScript on Keypress key string void already. Reconsider that API because on Keypress Q doesn't tell you what this is. A browser key, logical symbol, physical position, automaton symbol, UI label. Those are different objects. Something closer to on input or on key down would fit better. More importantly, both input paths should converge. Physical keyboard input. Adapt your virtual keyboard WASM engine. Your virtual keyboard does not have to construct a real keyboard event. It simply sends the same information your WASM API requires. 11. One thing I would change in your current component is TypeScript constructs Q, W, E. Currently mixes visual label input identity. They're both Q only by accident. You may eventually want display label Q symbol Q physical code key Q. So conceptually I would eventually let each virtual key contain an input descriptor rather than just display string. Not necessarily now, but the distinction is important. Key view label input instead of key Q that makes the UI representation of an input. Source rather than the authority on what Q means. 12. First actual WASM milestone. I think your first functional Rust / WASM milestone should be smaller than sound. Press Q downward arrow WASM receives it downward arrow Rust returns it downward arrow. Automaton consumes symbol ID downward arrow Rust returns debugging result downward arrow console shows symbol underscore ID 0 old underscore state 0 new underscore state 1 then press W symbol underscore ID 1 old underscore state 1 new underscore state 2 then press Q again. Symbol underscore ID 0 that immediately proves WASM builds. V loads it. JS glue works. State persists between calls. Strings cross JS rightward arrow WASM. Dynamic symbol interning works. Automaton state persists. Rust returns data to JS. Then build an oscillator. That gives you a solid experimental substrate instead of debugging web audio and WASM simultaneously. 13. Loading the WASM with V for your current stack. I would use WASM pack downward arrow target web downward arrow generated ESM JS glue generated. WASM generated TypeScript declarations. WASM pack build target web is specifically intended to generate browser loadable ES module glue around the WASM binary. The generated default JS export initializes /loads the WASM module. WASM binding plus 1 so I reserve something like web src WASM key2 wave. TS package generated take is generated. Your handwritten key2 wave.ts is the one place React knows about WASM initialization. Conceptually, TypeScript import init engine from package key2 wave underscore WASM then await init then new engine the official target web interface uses exactly this model ESM import followed by asynchronous initialization. WASM binding 14. I would isolate loading completely from React output. WASM init WASM import engine construction inside app. TSX have web src WASM key2 wave.ts on that boundary. Something conceptually like initialize key2 wave downward arrow returns engine then React sees engine not WebAssembly. Instance WASM file WASM binding initialization module URL your architecture becomes React web src WASM key2 wave. TS WASM binding generated glue key2 wave WASM key2 wave core the key2 wave.ts is your browser side adapter. 15. And the WASM asset v has native mechanisms for treating the WASM as an asset /module including explicit URL imports with URL. Vitalities plus 1 so if you want the loading path to be completely explicit rather than trusting the generated relative URL resolution. A robust shape is conceptually TypeScript import init from package key2 wave underscore WASM import WASM row from package key2 wave underscore WASM underscore bg WASM URL 18 WASM URL actually let that for this project specifically because you're trying to understand the machinery. It exposes the chain. V resolves WASM asset URL downward arrow WASM binding init URL downward arrow fetch instantiate module downward arrow generated JS glue connects imports exports downward arrow Rust exports usable rather than making initialization look magical. You don't need a WASM plugin just to establish this first WASM binding target web workflow. 16. The skeleton I would aim for I make the architecture browser keyboard event virtual key keyboard input code key phase repeat timestamp web src WASM key2 wave TS WASM binding API key2 wave WASM convert API primitives key2 wave core keyboard input symbolizer string rightward arrow symbol ID symbol table automaton state transition engine output WASM React UI then the next branch becomes automaton transition sound action synth vec F32 playback waveform display and later automaton transition downward arrow wave mutation downward arrow persistent sequence wave buffer downward arrow manual play button those two modes you described immediate instrument versus constructive waveform composition can therefore share exactly the same input architecture. What I would build first I would make the first Rust API only large enough to support this experiment. New engine keyboard underscore event phase code key repeat timestamp current underscore state last underscore symbol underscore ID symbol underscore count reset no audio no web audio no oscillator no giant keyboard enum no JS object serialization no WebSYS required yet either because JavaScript is supplying the browser data to Rust. That last point is particularly useful. Your initial WASM crate can use WASM binding without Rust touching the DOM at all. WebSYS only becomes necessary when you actually want Rust itself to invoke browser APIs. WASM binding is specifically designed to expose Rust functions /types to JS and pass values such as strings across that interface. WASM binding plus 1 so your very first vertical slice can be beautifully small. Keyboard event downward arrow 5 primitive arguments downward arrow WASM engine downward arrow intern string downward arrow symbol ID downward arrow automaton transition downward arrow return state downward arrow console.log. I think that is the right skeleton for what you're actually trying to build.
So there's basically a bunch of questions that I have. I'm not really sure. It's kind of tough to know for sure if I should ask the LLM to these questions or just look into the documentation. Probably if there's time. Keyboard events. I think I should send this char code. And the immediate question that I have is around the type. That's the one. So it's both around the type and around the structure here. Because I'm not really sure how to do this. on Rust. Maybe I'll just change the. I think that the level on ChatGPT there, it determines how long the answer is. I'm not really sure if that's true or not. So I'm gonna try to get a shorter answer. And what I need to figure out is like how to expose. I think it's telling me to do the engine here. It's probably gonna be. So how should I call this? Maybe just key to wave engine. Just gonna call it engine for now. Also, we need to do pub. And then the first question is, there's a bunch of questions actually. But I think the main question is how does the conversion work? Because I'm thinking about the boundary between the WASM and the JS side. So like from the JS side, I think the best thing to do is to try to send all the data that I have here. I'm gonna receive from the event, and then I'll let the Rust side decide what happens with this data. It's probably I think that makes most sense. Then obviously because how does the function work? I need to figure out how to do the WASM first. I should load the WASM file. So compile the Rust, then do the WASM file. Integration with this thing here, which might be annoying. So let me think about this. Kind of annoying because I don't want to spend time like figuring out the CSS stuff and the HTML stuff. And I already have like a pretty clear picture on my mind of how it should work, I think. But then the details is kind of the annoying parts, like how to do the WASM and then compile this. Trying to think about the best way to ask GPT. I think to expose here, you just do mods, maybe a pub mods, engine. I'm not really sure if I should do tasks here. I'm just gonna remove. And the other thing that I don't understand is why GPT recommended this separation here. How I'm gonna use the engine on the WASM. I'm just gonna write down the questions that I have. The obvious, like the error, like TypeScript is kind of annoying, and I assume that the error is happening because it assumes like I should put this type there to receive, and it shouldn't be a function. But then I don't understand. I'm like thinking about, am I not supposed to be to put a callback function on here? So I assume that I'm probably using the wrong event or something weird going on with the types. So that's the first thing that I want to clarify. And then here, the other thing that I don't like that much that I'm thinking about is like this whole thing about passing the callback doesn't make sense to me. I think I'm just gonna remove this like from the app here. Doesn't make sense, I think. Should probably create a context or something like that. Or maybe a Zustan store. But then like the question is whether or not it's gonna get annoying and then distract me from the actual thing. Because I think that the reason why the agent did things like this is because I need to connect both. So setting up to change the state, the callback changes the state on this component, and later on you pass the state here. But I think it makes more sense to have a, or I should put, let me think. So I'm thinking that they should probably be parts of the same component, and then that avoids doing the context in the first place. Yeah, but then the wave, the state becomes confusing. I think I'm gonna use an agent to do this. The problem, like, I'm not really sure because like this is not related to what I'm trying to do. And I already know the main thing that I'm going to try to figure out myself is this boundary. It's basically on the Rust side that I'm more interested on. And then the main thing that I want to figure out is the boundary between the WASM and the Rust, the JS codes, when it comes to the types. That's the first thing. Then the annoying thing about this here that has like some friction is that I'm gonna have to delete this stuff, and then I'm gonna have to. I don't really care about the UI when it comes to the keyboard. Is I care about the core essence of the logic, which is basically capturing the keyboard event and then translating that into a waveform. But then what I'm thinking about is like what is the best way to do this? That is not very annoying. It's not going to deviate too much from what I'm trying to focus on. And for that reason, I'm contemplating on using the agent to refactor, but then I can get like sidetracked in another rabbit hole because then it might require me to use a context, and then it's just gonna. This is the biggest problem with using agents is that you just accumulate a lot of entropy. And then like at first it might seem fine, but then it becomes like worse to deal with everything. So I think before I do this, I need to figure out where is the best place to. Uh, it's probably better to focus on creating the Rust side first, then I compile to WASM, then I figure out how to do the WASM glue, because then I have the bridge entry point to the JS side. And that's what I should do probably. And I'm probably gonna load here, I think. Actually, I think it's probably better to load inside of a component or inside of a class, then expose the class in the component. Probably the best. The class is faster. So initialize the WASM. So I'm gonna ask first. There's another thing that I'm thinking about that makes sense that you have the controls on the keyboard. The controls are like the parameters that are gonna change like the simplified version that I'm thinking about. This is what I mean that I already know, like how this is gonna work on the architecture. Is you have the keyboards plus controls or parameters on the front end side. Then on the Rust entry points, you have a function that receives this parameters, and that's the engine function. And this produces or processes based on a finite automata processes, and it creates audio waveform as a side effect. Then once you have the audio waveform, you send back to the front end, and then the front end produces the final wave. Then you play with the audio, HTML audio. That's what I'm thinking. But then the annoying parts that I'm not really sure is like how to translate, how to exactly compile, and like the relationship between, because I think on the engine makes more sense to put on the core. And actually, I kind of regret like having the name like this. It should do just core and WASM, but. So the engine is here, and the WASM is gonna be the bridge between the two, I think. I'm trying to clarify the relationship between the core and the WASM. If I'm building how to compile as fast as possible so that I have the final WASM and the glue. And then what is the best way to do this on here? I think obviously I should do inside of this thing here. So what I'm thinking is probably I should create a class on a TypeScript class here that loads the, or maybe a context is better. Like maybe both actually. So I have a class to load the WASM, and then you have a context that uses the class and exposes to the rest of the application. Then wrap the application around the context, so that's probably the best thing to do. So I'm gonna need a context here. And the question is like how to the best way to load. I want to read the response and think about this. But I'm pretty sure I need a. I'm contemplating whether or not to receive as a parameter. No. But I think I should just like hard code because it doesn't matter that much and it's only gonna have one thing there. So I should hard code the URL and I'm probably gonna put the files on the WASM here. It's gonna be the same path. I think it's probably better to compile to WASM first, then get the glue, then figure out how the shape works of the API, then figure out how to load. Yeah, that's the. And once I have this bridge clarified, then it becomes easier to start adding stuff to it. I think that's probably the best path. What I'm realizing as well is that it's kind of dumb probably to do like two separate folders. I just did that because of GPT, but I think because like I don't really see. Maybe there is a point, but I think what's gonna end up happening is just like compile to WASM directly on the core. It doesn't make sense to have two different folders. I'm gonna ask that next. Kind of annoying as well because there's the friction that like to copy and paste files. I'm trying to figure out how to decrease the friction, but I think that's the only way is just to build, like manually build, resist the temptation to use an agent, manually build a bunch of times until I get the patterns. Because the problem is like I'm a lot faster on the implementation, like I already know how everything should work. But then to actually implement, there's a lot of friction because of this, all these details about the language and with the tooling. That's the reason why I was talking about like whether or not you just search on the documentation directly or the LLM. It's kind of like a double-edged sword because the LLM usually like is more, it gives a lot more information that is kind of useless, but then if you search directly on the documentation, it's kind of slow because oftentimes the documentation is not very good. I forgot the name. Hmm. WASM engine. I'm manually typing to see if I can like retain better. It's not really. Maybe if I do like this. Now that I'm gonna ask how to if I want to expose like that. How should I do it? Engine is private. As my engine implement. It's actually on both of them. But it's telling me to do this on the lib.rs, but I want to do it on the engine. My engine. Hmm. Yeah, I'm not sure if I trust GPT here. I think you should probably just do one crate. It seems like a waste of time. Maybe because of this library separation here, the dependency separation, it makes sense. But like it ends up seeming that it's just relaying. Like I'm gonna have to duplicate everything on the WASM and just call the other engine, which doesn't make sense. That's a good point. Like it's creating a separation, so in case I wanna do other stuff with the core engine or using on a different environment, I can. But then I immediately think that's like wouldn't make more sense to just use like the different flags because I've seen on the other like other projects I remember you can do based on the configuration. So I'm gonna ask that. It maybe makes sense to leave it like here instead of these crates because I might add other crates later. So I do think that I'm just gonna rename this to core. Yeah, core. I'm gonna delete this one. And then change here. And then I'm just gonna ask. So I'm pretty sure you can do it based on the configuration. And it makes more sense. I actually think I'm just gonna copy to go faster. I'm kind of concerned that if I copy, I'm just gonna avoid doing the work. And then you just get into this endless loop where you become more dependent on the LLMs. I'm not really sure how to strike the balance yet. Because I think when you copy like directly, it becomes harder to memorize. But then if you try to come up on your own, then you have to use the documentation. It feels very slow and inefficient. Not really sure what's the best way to learn fast on like this stuff that like just basically remove all the noise that usually is like these things have. And this is the thing, like this symbol, that's the stuff that I was trying to clarify. I guess it's fine. So like restarts like this, then I'll think about it later. It's not really a string. So the question that I have is more fundamental, is like how does it work? Because how does it work on the bridge between the WASM and the JavaScript? Because obviously it's going to be two different environments. Yeah, the thing that I'm not sure is about this, like this thing here. But based on other projects that I did, I think it makes sense to do them on the same thing, but maybe it's wrong. No, whatever. Just gonna ask GPT. Be right back. Not sure if this is the best way. It's probably better to use a ref, then instead of doing the thing that GPT did here with the static, we initialize inside of outside of a function. Initialize the WASM outside on a function, and then pass to the constructor. But it would be like basically the same thing, because the static is as if it's an outside function. Maybe this is the best. Maybe the only thing I will change is the using a ref instead of the flag variable. I think I'm gonna leave it like this for now. This is kind of weird. Doesn't make sense. So now gets into the, like, I'm not really sure about how I'm gonna do this, like the architecture of how to receive the events. I think I should probably do it on context. That makes more sense. Instead of having this function here, I have the function on the context. Not sure what's going on, why he's not capturing here. I'll find module. It's because it's not default. I think I can't, like I have to do the other way to do this. Or maybe not. Hmm. Hmm. I think it's just an IDE thing, probably. This stuff here. That's because I didn't. Yeah, it's not working. So I'm pressing keys and then it's not logging. I think it's because of the instance thing there. Or it's because of the initialization, because of the thing that I was saying about use graph. So the way that the context works. Might be like one of the, based on Vite, the way that Vite handles the imports. So maybe it was that. But I still think it's not gonna work because of the it didn't work. It might be because of this instance thing here. So this. That's because I'm yeah, it is working. So yeah, I forgot that it is reacting to the clicks, not to the keyboards yet. Now let me think about the architecture. Yeah, I think that the first thing to think about is, so obviously I'm gonna remove the count variable there. So I need to think about how to. There's one thing that I was thinking about before even doing everything, and the other thing that I'm thinking about now. The thing that I'm thinking about now is how to put the shapes of the. So I basically need to capture all the information from the event. I think it makes more sense to change the front end first. So instead of making based on click, I make based on keyboard shortcuts. Then I send all the data basically to the function. And then the question is on the Rust side, how to convert that. And I'm assuming that I probably have to send on like as separated arguments, obviously, because of the type, it's not gonna work. So I think that in order for the bridge to work between the Rust and the front end side, you need to have both sides need to support the same types, I think. There's gonna be the primitive types, but I'm not really sure how it works. The constraints probably, yeah, it's kind of like a tunnel between the two different language spaces, and the constraint is the topology of the WASM language. They both have to satisfy the WASM. I'm assuming that's how it works. So probably most likely what I'm gonna have to do is just look at the type. So first I'm gonna ask ChatGPT how to. But then there's the other thing that is like how to structure the actual components so that the flow of data makes sense. But I'm gonna probably what I'm gonna do is just ask ChatGPT to give me an updated component that works based on keystrokes instead of this. And yeah, so the question is how to capture all the key. I'm not really sure if I can do like a keyboard shortcut thing, like to get all the types of keyboard shortcuts, because I don't want to be trapped in fixed symbols. That's the challenge. And this goes into the other thing that I was thinking about, which is what I could do potentially is to have a file and then I create the rules based on the file instead of creating the rules. So you create the rules based on data for the finite automata instead of making it based on discrete symbols. And the thing what I'm trying to think about, like how to avoid is, 'cause from what I understand, the way that the finite automata works is that you have like a bunch of rules. So basically, you have a match statement, and then each match statement has like a branch, and then you basically like check based on the current state what is the symbol. So you compare the symbol, like basically, let's say you have the letter A. You compare to see, you go into the match, then if it is A, you go to the other node on the graph. And then it keeps going to see if you have a valid string or not. Something like that. But the issue with that is that you have to hard code each portion of the branch, which I'm trying to avoid. So let me think about what the name's gonna be. And maybe just like make it uh, like this. It's actually a vector of F32, I think. I think that this is how audio data looks like. Not really sure. This is where I can use like other crates as well, and then I'm gonna have to use other libraries. I'm gonna have to see like how do they work. And then here you would like I need to have. So the first thing I should clarify is what arguments I'm gonna have there. Like what's the shape of the keyboard event input. Then I separate that into arguments, that becomes parameters. But the thing is, let's say you have a string. Less symbol is actually better, I think. Description. Then you would match. Yeah, I'm not actually. You need to loop over. Not sure actually if you need to do the iteration on the slice, like 2 iter or something like that, or 2 bytes. Yeah, I think in Rust I don't remember if you have. I think you have a default way that it is encoded. And it's probably UTF-8, but then you need to use the other functions if you want, the other formats. But I'm not sure about whatever. I'm just gonna ask GPT. Then you match. And here we would have like A, and then you check to see if you go to the next state, I think, or something like this. I don't remember really well. But for my case, what I'm trying to think whether or not if it's possible to, instead of hard coding each rule here, I have like some way that I do it based on data. Because hard coding every type of keyboard input you can have is kind of annoying. But maybe it's not that big of a deal because it's gonna be a fixed space. So first, let me clarify what is the shape of the keyboard event. Also, I should remove the whole thing about passing the context. I should just call the function. So use the context, call the function, and remove the other stuff. And then I have a reader. The waveform component is a reader, is a consumer of the context, and the other components are producers. Then maybe I think you should probably make it a class actually instead. Like on the same class of the engine, I do all this stuff, and then I have a function that subscribes to that, to state changes. But that makes more sense because then it is immediate. Like instead of going through the React cycle, you just do the stuff under the hood through the class. And what I'm thinking about is that the waveform component subscribes to state changes on the class, and then the other classes change the state of the class by updating the parameters. The class contains the state, the functions, the components expose the functions. But then I have to figure out like how to do the event, which might be force me to do the events like event emitter. I think I'm just gonna ask ChatGPT to do this. It's probably the best way. The best way to do this is the same way that I did on other projects, just expose a function. Like you create a function that exposes an API to the class, and then you wrap that API on a context, on a hook, and you access that. But I'm not really sure if I want to do that. Let me think about this. Like there's two things that I'm trying to change at the same time, so maybe it's better to just change the front end first and think about the class later. But the way that I'm thinking about it, the class here, like instead of changing the state on the components, I just make variables instead of this class. That this class becomes like the state of the audio waveform. Then I have an event here that captures the state and uses a reducer pattern. But I'm not sure because it is kind of annoying. Like there's more things that I have to do that if I go this route. But the other way would be like the other way is worse, I think, because then you have to put the state on the React side and then it becomes slower, I think. Then the components that right, which are the keyboard and the control, they call a function from the class which changes the state and emits the event that the state changed, and then the waveform component subscribes to this state change and changes its state based on that. I think that makes this probably the correct thing to do. It's kind of annoying because you have to do the event emitter, but I think that's what I'm gonna do. But the first thing I have to change, I think, is this component here. So instead of sending a string, I send the keyboard event. And that's the first thing. So basically everything that is used by the waveform is gonna go to the class as the state. So everything that makes up the wave is on the class as a state, and the inputs are the on function parameters inside of the class. So the keyboards or the controller receives the data as an input, as a parameter inside of the function, which calls the WASM, which which has a finite state machine that converts those events into audio data, and then it returns values that then change the state of the front-end side class. And then the waveform reads, it changes the state based on those state changes on the class. But I think this web sys is gonna fuck me up on the compilation. It's probably better to split the input as like built-in types. When it doesn't. I think I'm gonna stop here. I'm gonna continue to do this off string, and next time I'm just gonna like fix all this stuff that doesn't really matter because kind of annoying. And the most interesting part to me is the finite state machine later, and like it's kind of, I don't know. There's just a lot of friction to like these parts that I already know like what to do. So I'm just gonna ask GPT and then like just try to quickly solve all of this stuff, use an agent or whatever. And once I have the bridge, because now I already have a clear idea of how it's gonna work, and I'm gonna have to spend some time thinking about like how to. The most interesting part and most difficult part probably is the finite state machine. Figuring out how to what cool things I could do to create actual sound from the keyboard. Because here basically what I have to do is just like figure out how to make this like I'm gonna have to compile this again, then figure out how to make this work, then parse this stuff, then like change the keyboard here. So that's this thing I'm not really sure about. ChatGPT is saying to hard code the keywords, which I don't like very much, but I'm not really sure if there's another way. Like what I wanted to do is based on the like if there is a way on TypeScript to just loop over all the possible keyboard shortcuts. Not sure if that's possible. And you loop over that, and then you just call the functions, and then you change the class to subscribe. Yeah, so I don't feel like doing this on string. So probably next time I'm gonna finish doing this off string, and then next time I'm going to probably go back. I might spend some time trying to figure out the translation between the symbol to the waveform. That's the part that I'm most interested about, and also like how to set up the parameters of the wave. So like the controls, it's also interesting. You have the frequency, duration, volume here, but then possibly there's a lot more. And I think once it gets to that point, it's gonna be interesting because then I can start like building machine learning and experiments. And this part's just annoying. I'm probably just gonna use an agent or GPT to quickly solve this upstream. And yeah, so next time I'm probably gonna continue to build this. So see you then.